Okay, so within the interface of Grasshopper, you just double left click to create a search bar, and then you can search for any sort of command. I want to reference in a mesh, so I type in mesh, and then I get a component that is a mesh, and this, if I select it, it says mesh. So what I can do is select this object, right click on the mesh, set one mesh, and then it becomes green. If I select it, or if I deselect it, it's red. So now it's referenced within Grasshopper. Okay, and then I can do simple manipulations just as you would within CAD, but I'm just double left clicking and searching for the component that I need. For instance, I want to move it in the Z direction, just 1 unit. We'll do that. The most powerful thing in Grasshopper is a number slider, and that gives you the ability to change things and update them really easily. You can right click on the slider and change all of these values, like change how many decimal points there are, that sort of thing, and then whoa, yeah, your banana moves. So you can obviously do all sorts of other manipulations. So say if you wanted to rotate the banana as well, we right click on the input, and then we can change a few of the options. Here there's an option for degrees, so then I can create a slider strategically as well. So negative 180 to say 180 will give you that exact range of values, and then you can rotate your banana. Yeah, so then, or you could do a combination of these things. Let's see. And create all sorts of things. So let me just change this domain to 180. So that sets the target range, and the source range is 0 to 1. So if I create a 0 to 1, 1.0 or 00 slider, it'll give me that resolution. Okay. I'll put that in the mapping thing. There, that just rotates it, and then I can create another mapping thing so that my domain is just, say, 0 to 10. Put it in there, and then I can do both. That's parametric now. Okay, so one slider controlling two values. That's the basic concept of Grasshopper, and there's infinite applications for this. Right? Anything that you can create some sort of mathematical relation with, you can do within Grasshopper through geometry manipulations, and yeah, relate both of them. Yeah, so that's the idea behind Grasshopper in general. However, so I'll save these as like just really simple examples. Sure, I have a folder. I'm going to get rid of this now, and I'll just save as I go. So with that mesh, what I want to do is slice it up into a series of slices. So I'm going to go into the top view. I'm going to lock that object so it stays there, and I'm just going to draw a curve that roughly represents this banana. I want to put project on so that it doesn't have any sort of three-dimensional kink in it. I just want it in the ground plane. Okay, so you can manipulate this curve in Rhino. Sorry, you can't see it. Once you reference this in, so I'm just selecting that curve and set one curve. So now, maybe we want to hide this. So right click on one of the components and set the preview off, and you can right click to unlock this, and I'll just hide it so then you can see this. So the red line, I'll just pipe this so that you can see it a little bit better. If you manipulate this, then the Grasshopper code updates. So there's a direct link. Another shortcut, Control Q, turns on and off your preview, so toggle. Rid of the pipe. Okay, so along this curve, now we're going to create some divisions. Divide curve, however many times. Okay, so we've got a list of points, each of those 11 points. Then we can use a point list to display the numbers of those points. So we've got 0, make it a bit bigger. Okay, so there's a list of points, 0 to 10. So we've got 11 points. And I can plug those into the origin, so it'll create a plane for each of the points. They're a little bit big, so I can go to display and change the plane size. And then, because I've got 11 values here, for the tangent vectors, I can throw that into the Z, and then we get a series of planes that more or less follow the shape. And then what I can do is find the intersection with the intersect pane up here, and find the mesh and plane intersection. And then I'll just hide the rest. So then we get our contours along the object. Okay. And then, yeah, so that's, I'll save that as the contours. Okay, so now I've got a series of values here, and you'll notice that, yeah, so just creating a panel so that we can have a look at the lists within this. I'm not going to go into too much detail about data structures and stuff. We want to just try and keep it as simple as possible here. So what I'm going to do is just flatten this out, so that now we've just got a nice list of 0 to 8 of all the objects that actually intersected with the mesh. Okay, so now if I do like an area centroid, I get a centroid, and then I can get the numbers for each center point of each of the objects, so you can see 0 to 8. Okay, and then next step, I'll just hide this so that we can see, and we can change change the numbers, and now we want to display the material thickness next. So we can simply extrude these ones. But we have to pick a direction, which will be the tangent vectors, but we come up with the problem that because not all of the planes intersected one another, so I'm going to create a bit of a fix there where I base it on the geometry, so I can extract the normal vector from this geometry, so that everything is still referenced to one another. So we can get those planes from the curves. They might be all over the place, but just for now. Origin. Face plane. So there we go. They still look a little bit skewed and funky, but at least they're in the center of each of those objects now. Doesn't really matter. And then we can extract all of those Z axes from those planes for the direction. So then everything extrudes the correct direction. So we got the direction correct now, we just need to change the amplitude to our material thickness. So I'll just create a panel for that, call it material thickness, give it a 3 mil thickness. Whoa, object is really small. Let's do it out of card, tiny banana. So something you have to consider now, I guess, is the scale of the object. I think I just right clicked on show that to show objects. I'm just going to scale this in every direction from 0. Oh no, oh, okay, that's good. And we'll make it say 10 times bigger. There we go. Awesome. So now let's make it 3 mil thick. Cool. And then cap these objects so that they look solid. And then preview them. Give them a nice color just for the hell of it. Nice banana-y colour. Ugh. Really yellow banana. There we go. Alright. Yeah, and then you can change how many divisions you have. With another slider, maybe. You can just type in one number and it'll default to something like that. And then, yeah, create more or less detail. Cool. Okay. Good. And then, where are we up to? Okay. There's a bit of this that I'm not going to do now because I'm too tired. I'm going to upload for you. Because the next bit I'll be umming and ahhing way too much. Yeah. Oh no, I'll have to delete stuff over that. Alright, so we're material thickness now. Okay, so I defaulted like that. So this is the basics of the ribs, but the next bit is the bit that connects all the ribs together, which is a little bit more difficult and might take a few more components than just these few. So I'll make another video for that to make it nice and robust. Otherwise it might break. But the basics of it is that we'll create a slot in each of these for you to just laser cut out something in plan that then this just slots onto. And then so the thing in plan will have like teeth that go like this. And that's the material thickness.
3.
Yeah. 3 mil. And then you just have a slot in each of those shapes.
Do we need put more extra tolerance? Or just 3?
Just 3 is good because the laser cutter has a slight thickness to it.
Oh,
yeah, so it gives you a bit of leeway. Yeah, and with these, these are you could make them nice for sure, but the idea is that you just make quick prototypes and test things with it. So we're going to test out all sorts of different visualization techniques, visualizing airflow around it within the wind tunnel when we set it up, hopefully next week. See how we go. I might have to ban the troops to get it ready on time. We'll see. Otherwise I'll probably be having another all-nighter. Yeah, it's necessary sometimes. Okay, so where are we up to? Okay, so I just did the standard method of extruding this, but there's other sort of details that you can go into. Say, for instance, the offset of the thickness of the material. Do you want it centered to your plane, or do you want it offset slightly, or whatever? So I'll just center this by putting a little move component in here with another. No, so this one I'll introduce you to equations that you can create, expressions that you can create within these components. So you want negative x on 2, so it moves it backwards half of the vector. Where are we? I need some curves. Interesting. Yes, that's right. There we go. Sent it. Cool. And then I just go along and leave those up and shown. Make this look semi-interesting. What did she say? Cool. Okay. Alright, I'm gonna save that one and Alright, so I'm going to do a VROW curve intersection. VROW and the curve. Oh no. Something broke. I have to reopen this.
Yes, good idea, bad execution. So yeah, if you do want to play with it in 45, sorry for those who do not have access to 45, it really won't save you that much time, but it will be more enjoyable. I'll just say that. Yeah, so, yeah, sorry that you don't have access to 45, but you could work. I need them back. Okay, so here's the deal. Sorry to interrupt you.
No, go. I'm recording this. I've already explained to them that I'm way too tired to do this anyway.
Okay,
so,
should have put you an extra copy.
Oh yeah.
I'll grow up to level the thing and I'll get you a Kickstarter. The dealio is, you give them back Tuesday. You're responsible for them. If you lose them, you mistreat them, whatever, you pay cash for cash plus 200%. So don't lose them.
Okay.
Who else? Who else? Who else was it? Yeah, you and you. Okay. For those who don't have it, it's not super. It's just a better, more intuitive experience. I'll try and see if we can get you into that later on, but I just thought to start off with, this is what we'll do. It's good that some people at least have an experience and they can tell you what it's like. Yeah, that's as good as we can get. It used to be the case that all these used to have lifetime labs and we used to be able to get class sets. What happened was a few people stole them and then screwed it for everybody. So don't screw it for everybody. Is where I'm going with that. Yeah, it's just a different type of. Dan, you played with my box over last weekend.
Yeah. I was telling them how awesome it is.
Yeah, with a mouse.
Super fun, even just with a mouse. But as soon as you get on the Wacom, heaven.
Exactly. If anything, the Wacom will probably make you take longer, just because you get so obsessed with it. So probably, it's a poison chalice in that respect. But it is, it's just a lot more. The user experience is really fun. And then you can just report back to everyone how cool it was, and in the meantime we'll try and hustle and see if we can get access to the lab somewhere.
Yeah.
But Tuesday morning you have to bring them. They're currently under my name, so I get blacklisted if you don't get them back. So I'm taking a higher risk. I'm taking a risk, hopefully not a high one with you. But there is certainly a high consequence of that I won't be able to borrow anything from these guys. And that includes the case as well and everything. So all back in one go. So that's Lois, Aksha, Nicholas, Neon, and Shagun. Cool. I'm gonna get you just like crappy coffee and I'm gonna fill this up.
Thanks, man. Yeah, that'll be awesome. Whoa,
and then when we come back, we might just discuss what's gonna happen on Tuesday. All that.
Oh, that's so messy.
So the style is specifically for that part. So if once you want to use the part extrude and you have it,
The one,
yeah,
the
you can
big
still
thin
use your
one.
part, but like super for the
200% flow down.
one time I put
No,
the
it doesn't put the control. You know how important this kind because it's powerful.
Guys, let me just show you the manual version of what I'm gonna do, so that we can at least cover the basics of how you today. Guys. So just want to cover quickly how you get geometry from Grasshopper back into Rhino and how you use it. Find these ones. So what you can do is right click on that and hit bake, and then just choose the layer that you want to use. So I might go layer 1, and then I'll save this pixel and go to the layers, and then all of that geometry is on that layer. And I've got some hidden geometry, so maybe you want to change that layer, so that's the banana. And then the reference curve, I'll just put on a reference layer, because it's just a reference geometry that we want to use. I'm just going to use this one to demonstrate what I was going to do, more or less. It's not going to be perfect, but it gives you the idea. So I'm just going to offset that, the material thickness, even though it's bent, I'm going to fix it. No, you don't want a material thickness, doesn't matter. I want something relative to the scale of the banana, so it could actually be the extent of the banana itself. And I'll probably do it that way, yeah, without getting too sophisticated, because we just want these to be quick. Yeah, so I'm just going to offset this tiniest little bit, and we'll just do 3. That'll do. Just reaching those guys. Right, just going to do this really quick, just putting curves on the end there. I'm going to copy these over to this layer. Right, and join that planar surface. This stuff you probably won't have to do, but yeah, just showing you what the process will be within Grasshopper. So extrusion distance is material thickness. So then we've got some sort of thing that these objects can slot onto. But we also want to, where is it? So yeah, extrude. might just have to move this up 3 so it covers the other bit, and then we just select. I thought, oh yeah, so these are the ribs. Select those objects, and then Boolean difference, cut everything out like that. Put this one on a void layer, and then oops. And then that thing can pretty much slide in there, kind of, but I ruined it. But at least you get the majority of them, and you can just literally just like glue them in place. But you can also, instead of only doing that little bit of offset, alright, cheers. Let's find that curve. Where are you, curve? Ah, rip. So we can offset either side, say 3 on one side, and then 6 on the other, and then do a similar thing. And then just go down the material thickness. Oopsie. Up. Okay, and then do a Boolean difference again with all of these guys, but instead of doing it the opposite way, so we cut out all of those sections. So then we know which position all of the ribs go in. And then, voila, banana. Yeah, so that's basically the process, minus like these shitty little things that we don't really care about, and we can just like cut off and make into the banana shape or whatever shape that you're trying to get in the wind tunnel and do experiments with. The more, the quicker you do these sort of things, the better in the beginning, and then you can refine the process later if you find that you have this sculpture that you want to throw into the wind tunnel and make really beautiful. So you can sort of imagine how you can create this sort of contrast in material qualities and light with this physical model, because you're creating this sort of like MDF ribbed structure that you could potentially paint. So a nice clear color, just one color, and then have white fabric over the top that's stretched and only attached, say, at the end, so that it doesn't have any glue marks or anything, the ribs, and then just backlight it, and then you get that light coming through the structure and the shadow lines and everything that's showing up. It can be a really beautiful object in the end. Really beautiful banana. Yeah. So I'll save this as where are we up to? This is like 04-ish for the banana. Just throw that up there. Oops, I was doing that. Okay, so that's what comes next. After my half attempt at the parametric version, which I'll probably have a nap later and then complete it. After a few beers, I think.
Yeah, well, Ian has said we should go buy the Lincoln, so I was like, yeah, we can, depends, our timeline.
Yeah. So Okay. Yeah. Let's stop this one.